So, first question. It's on freeze. Thank you. First question. 15% of 48 meters. No calculators allowed in this drill. So if you're new to the group, you didn't get the advantage of what discussion we had last week. So you'll have to wait until we go through it if you're not sure. A couple of seconds. These are supposed to be reasonably quick, and the idea to remind you from last week is, to improve your mental arithmetic a little bit, to give you confidence with this basic maths. Number 2, 3/5 of £12. Supposed to be able to do these in your head, so think about, there is a shortcut somewhere to do this, which I'm looking for in a way, so think about how you might do that in your head. 3/5 of £12. Number 3, factorize. Now, of course, part of this is what do I mean by factorize. We'll talk about that, but factorize that, which is something you're going to need to be able to do. Shouldn't take a few seconds if you know what to do. So moving on. Again, something we need to talk about. What does that word mean? Simplify. Simplify that expression. So some awkward ones here, but it's as much about introducing things to you and learning a process as to whether or not you get them right. So don't worry too much. Next. A third of x is the same as x divided by what? So what's the missing letter there algebraically? Which we were talking about last week. 6. What I'm asking here is for the voltage, but I'm asking you to remember the formula that we had last week. I think it's important to remember some basic formulae, so I'm not giving you the formula. What's the voltage there? Number 7, half plus a third. Tricky, that one. Number 8, estimate the length of this room in whatever units you deem appropriate. The length, so by that I mean from front to back. Number 9, now you can use your calculators for this one. For those of you who weren't here last week, we did this last week, so they've got a head start on you. Calculate P to an appropriate accuracy, so remembering what we were talking about last week. Okay. Should be quick. Don't want to copy it out, just do the calculation, that's all, and then write your answer to an appropriate accuracy. Yep, there isn't a 10, so that's it. 9 questions. Let's go back quickly and look at them and just bring out some of the main points. I'll go reasonably quickly. Stop me if you want to just add anything or you're not sure. Okay. Number 9, that was that one to do with that pressure, find the pressure. Okay. Only 9 questions. So 15%, well last week we were talking about finding 10%. I would find 10%, which is 4.8 meters. So if 10% is 4.8 meters, then 5% must be half of that, which is 2.4 meters. So then I'd add them together to get 7.2 meters. So 15% is 7.2 meters. The idea of finding 10%, and then that allows you to quickly find other things like 5%, as we were talking about. I will carry on unless you stop me and you want to talk about it further. Next one, 3/5 of 12 pounds. Well, 3/5, I want to find a fifth of 12 pounds, which is not that straightforward in my head, but I do know that 3/5 is the same as 6/10, doubling top, doubling bottom. So that's easy to find a tenth, because you just divide by 10. So 1/10 is £1.20. So therefore 6/10 is 6 lots of that, which must be £6, and 6/20 is £1.20. So £7.20 will be 3/5. You might have done it differently. Anybody want to? Yeah. Right, 20%, yeah. So what do you find 20% of it? How did you find 20%? Yeah, and doubled it. Yeah, good. Yeah, so a fifth is 20%. So we could use the same idea as we did on the previous slide. Excellent. Yeah, find 10%, double it to get 20%, which is £1.20, £2.40, and then we want 3 of them. So it's 3 lots of £2.40, which comes to that. Yeah. Anything like that. Factorize. Can we come up with an answer on this one? Yep. 8x over y. No, you can't. What are you trying to do there?
I just like the y out. So the everything over y. Be 3x over y plus 5x.
Yeah. So divided both of those by y. Hang on. 3x plus. So that means they're now all over y, of course.
so that'd be 3x plus 5x over y.
It would have to be 3x over y plus 5x if I want to bring the y outside. Yeah. You can't do that because that's over y and that isn't. So yeah, I can see what you're trying to do, and there's lots of good algebra there, but that last step was awkward. Yeah. Anyone else? Factorize means take outside the bracket what's common to both terms. That's all it means. What's common to both those terms? X. I can take an x outside the bracket, and then I have to ask myself what's left inside it. Well, if I divide 3x, what have I got to times x by to get back to 3x? 3. What have I got to times that x by to get back to 5xy? 5y. That's factorized. And if you factorize, to get back to this, you multiply the bracket out. X times 3 gets back to me 3x. X times 5y gets back to me 5xy. So if you factorize, always check by multiplying out to see if it works. We'll do more on this, so don't worry, if that's something that you're not quite happy with at the moment, but I'm just trying to introduce them now. The sooner I do it, the better. So that's what factorize means. Look for common terms inside each of the common things inside each of the terms, and then take them outside a bracket. That's what factorize means. Simplify. I can simplify this. Last week we were talking about what 2x plus 4x is. What's that? Yeah. Yeah. So I've got 3 outside the bracket and 6x inside the bracket. Do you remember last week what that means? Times, so 3 times 6, 18x. So it all simplifies down to 18x. We were talking about this last week. Remember, the third of x is the same as x divided by 3, x over 3. They are the same thing. A third of x is equivalent to, remember that symbol, x over 3. Comment on that? Yeah? You okay? This one, Ohm's law. Daniel? V equals IR. You need to remember that, please. V equals IR. So therefore, if I want to find a voltage, that means I've got to do what with I and R? Multiply them together. 5 times 3.6 in my head, times it by 10, 36, and then half it, 18. 18 volts. Half plus a third. This one's a bit tricky. Anybody? 5, 6. What did you do?
Times the left side by 3 and the right side by 6.
Right. Times top and bottom of this by 3 to make it 3 over 6. Times top and bottom of this by 2 to make it 2 over 6. And why have you done that? Yeah, this denominator has got to be the same. I can only add things that are the same. So 3, 6 plus 2, 6 is 5, 6. It's like saying £3 plus £2 is £5. You can only add the same thing, pounds and pounds, 6 to 6. If I had £3 plus $2, which I was talking about last time, I think, I can't add them because they're not the same thing. I've got to convert one to the other. So the key is, what number do 3 and 6, 2 rather, both go into? 6. So if you've got that, well done. Shows that you understand fractions. If you didn't, you need to do a little bit of extra work around that. Estimate the length of this room. You were at an advantage there, Josh, because you've got a meter rule, right? Did you see that? Did you come up with an answer? 8 meters. Anything different? 28 foot. Roughly how many feet in a meter? Yeah, roughly 3. So 3 is into 28. about 8 or 9, isn't it? 9. So you reckon about 9 meters, 10 meters, 30 foot. So about the same as that, sort of 9 or 10 feet. Okay. Well, there's only one way to find out. Measure it, but I'm not going to actually measure it. A pace. A good stride is a meter. So. Got me. A useful skill, this estimation that we were talking about last week. If you're doing a calculation, and you're calculating the length of this room, and you come out with an answer of 28 meters, hopefully you'd think that doesn't look right. Or if you came out with an answer of 80 centimeters or something, you think 80 centimeters, that's less, that can't possibly be that, you know. If you've got a feel for the right sort of answer, then you can check for silly mistakes on the calculator, which is what it might be, just something silly. 9. You bang the numbers into the calculator, and you get. You don't have a calculator? 960. Is that the answer you put? This bit about appropriate accuracy, what was that all about from last week? Significant figures. You go by the significant figures in the numbers you put in, and in this case they're all 3, so your answer should be 2, 3. Okay, so a better answer would be 4. What would it be to 3 significant figures? Because that's a 9, this goes up to 1. 481,000 pascals to 3 significant figures. Is that? You got 483, so there's argument over what the actual answer is here. 483, yeah. 482, 483. I think the right answer from last week is 483,000, if I remember rightly, so a slip up on the calculator there. But the key thing is an appropriate accuracy. We were discussing this last week, weren't we? This idea of significant figures. Okay, give yourself a mark out of 9. And then make sure your name's on it, please. So aim of today, a bit more on using formulae and making sure we've got this idea of engineering notation and standard form down, this idea of writing very big and very small numbers and using big and small numbers in formulae. So we're going to spend a bit of time doing that, and I'm going to give you a chance to have a go at some questions. And then we're going to look at these presenting data questions just to check everybody's happy with that, and I've already had some in. So I'm going to spend about half an hour maybe having a look at these, and then give you a chance to have a go at some. So those are the aims for today. So we're going to have a look at some questions. Think about what we were doing last week. Think about the sorts of things we have to remember to do to use formulae accurately. And then have a go at this and come up with an answer, please, to an appropriate accuracy. So, if I was going to do this, RT equals R1 plus R2 over R1 times R2. That's the formula. I'd identify the right formula. There it is. I've given in this case. So it's sum over product. Is that right? I've written the formula down the wrong way around. way. So first step, check the formulas right, okay, that you've written it down correctly from the formula book that you've taken, or you remembered it correctly. Product over sum. As soon as I started to say that to myself, I realised I'd done it wrong, because I sort of remember product over sum, and then I realised I'd written it the wrong way around. Easy mistake to make. I didn't do it on purpose, but it's a reasonable teaching point in a way. You know, check you've got it written down correctly. So once you've done that, then you're going to put the numbers in. 136.58 times 53.6 over 136.58 plus 53.6. Product over sum. And now I'm going to do it on the calculator. If you've got a calculator with this fraction button on it, use it. It gives you the option. As soon as you hit that button, you see this on the screen, and you've got a flashing cursor at the top, so you can write that, the multiplication, and then you scroll down to the bottom on your calculator and put the bottom bit in. So use that button if you have it. The danger is, if you don't, that you make an error, because the calculator might go wrong for you. So if we look at this, if I were to type into the calculator 136.58 times 53.6, let's write it down here. Divided by 136.5 plus 53.6, it's going to give me a wrong answer. Why? Yes, exactly right. It's going to divide by the 136.5 and then add 53.6 to that answer. So if I'm going to do this, it can do it. I've got to make sure I put a bracket round the bottom bit. So if you're going to use this button, you don't need to worry about that, because you've automatically got one over the other. But if you've not used something like this, remember the bottom bit needs to go in a bracket. So that's the sort of thing I do on the calculator. And then I get the answer, which is, as you had my calculator, the whole thing starts off with
38.4934.
oops, okay, 69, da da da. But now you're going to round it to an appropriate number of significant figures, which is 3, because we might have 5 there, but we've only got 3 here. So well done. The rule of thumb is go to the least accurate one, or maybe one more. So you could have gone to 4. And so what is it to 3 significant figures? Okay. So what goes afterwards? The unit, which is ohms, and then 3 significant figures, because you've rounded to 3 significant figures. So say that you have. So this is the sort of thing we're talking about. Okay? Perfectly okay to put that as your answer, because that's what you got off the calculator, but then round it to an appropriate accuracy. That's what I mean by give the answer to an appropriate accuracy. Don't forget the units. Notice the answer is actually smaller than the smallest resistor, and that's something I think we were talking about last time. Maybe it was with the other group. So that's unusual. If you add resistors in parallel, the total resistance is actually smaller than the smallest resistor you put in. And there's a very good reason for that, which I'm not going to go into. Okay. Now that's another formula. Same different resistors. Yeah. What I want you to do is to use these two formulas, because remember we were saying last time that they both are the same. So if I use this formula or this formula, I should get the same answer with these resistors. So what I'd like you to do is to use that formula, so it's the same sort of thing as you've just been doing, to this appropriate accuracy again, and then the bottom formula, this one here, and calculate the total resistance. You should get the same answer both ways. So have a go. Okay, let's have a look then. So if I use the top formula rather, well, we've practiced that already. So on my calculator, I would use the fraction button and I'd literally type in 36.5 times 14.62 on my calculator, and then underneath the fraction button 36.5 plus 14.62. If I didn't use the fraction button, I have to remember to put this bottom bit in brackets, which is not necessary if you use the fraction button. And then I get an answer, which would be 10.438. And so to how many significant figures? 4 significant figures would be? Okay, good, all well and good. So that's what we're looking for with the second one. The second one, 1 over RT equals 1 over 36.5 plus 1 over 14.62. So I'd use again the fraction button on my calculator, 1 over that, or 1 over that. Okay. You've also got, so as well as the fraction button on there that can be useful in these situations, you've also got maybe a button that says on it x to the minus 1 or 1 over x. So if you have a look at your calculator, you've probably got one of these buttons on here. So that would mean if I wanted to put 1 over 36.5, I'd hit 36.5, and then x to the minus 1, I'd hit that button. It would give me 1 over that. So I would type in 36.5 x to the minus 1 button plus 14.62 to the minus 1 equals. And that would give me 1 over RT. So 1 over the total resistance equals 1 over 36.5 plus 1 over 14.62. I want the total resistance, so what have I got to do? 1 over the answer. Okay? So whatever the answer is, I hit x to the minus 1 or 1 over x of the answer. And there's an answer button on key. Hit that, and then you should get 10.438, blah, 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 which you can then round. Try it if you've not done so. This inverse button, which is what we're doing, finding the inverse, is useful. Can you identify on your calculator 1 over x or x to the minus 1? That's a useful button because in this case we're after the inverse. Okay. Any comments on that? Right, formula to find the area of a circle. One of the formula I'm going to expect you to remember, if you don't remember it already, the area of a circle, pi r squared. A little bit of information about the circle. The distance all the way around the outside is called the circumference. The distance right across is called diameter, d for diameter. The distance from the middle to the outside is called the radius. Find the area if the diameter is 3.6 centimeters. Again, to an appropriate accuracy, please. So I'll just pause for a sec while you do that. Let's look then. So, what am I going to do on my calculator? Pi, you've got a pi button on your calculator, so don't type in 3.14. Hit the pi button, which is down at the bottom. So shift and pi often. and then times 3.6, half of the diameter is 3.6, so half of that is the radius, which is 1.8 squared. And I hit the x squared button to get the squared, and so that's literally, on my calculator, or the one I recommend, that's exactly what you type in. Pi times 1.8, hit the squared button, which looks a bit like this, x squared equals, and you get the answer, which is some 10 point. That's what you wrote down, is it? Well, that's about it. That's what 10.17 da da. Yeah. Is that the accuracy you go with? How many significant figures here? 2. So my answer cannot be more than, maybe one more than that. It's 3 at the outside. I've got 4 significant figures here at the moment. Notice that this 0 in the middle is measured. So those zeros at the beginning and the end are not counted in significant figures. If they're in the middle, they are. So I've got 1, 2, 3, 4 significant figures. So I could really do is going down to 3. So what's this to 3 significant figures? 10.2 unit centimetre squared to 3 significant figures. So that's the sort of answer I would be expecting you to write down. Okay, so we zapped through a few answers there, a few examples rather, where I've tried to show you how the calculator can be useful and some of the pitfalls to look for when you are using the trying to do fractions on the calculator. This is a useful button. What I want you to do now, though, is give you a chance to have a go at it for you. So, if you turn in your textbook, and I will put it on here. I've got an electronic copy, so if you've not got the textbook here, I'll put the questions up in a second. But if you have got the textbook here, turn to page 37, and it's exercise 19. So it's page 37, exercise 19. I'm now going to give you about 25 minutes till around about 12 o'clock to have a go at some of those questions. Working together, as is usual in this case, I'm going to put some background music on to play along with, but nice and quiet, please. Maths conversation as you're having a go at some of these questions. I'll put the questions on the board.